Welcome everyone. This meeting, so let's start with company update.
Yeah, I got my box from Common today, so we have two USB GPUs. I think that's the most exciting thing. Progress is being made on our custom firmware for them. We should be able to make it work really well over both USB 3 and USB 4. Our plan is to sell a board. As a company, it's just gonna be the board that's in the common GPU. It's an eGPU for sale for everybody. It'll be like 150, $200 or something. Broken out FTDI so you can access the chip, and yeah, that's the main thing. I don't know. Penny box sales went great this week. I don't know why. Gotta get Kimmy running on something. I want Kimmy.
Sounds good. Okay. Next is my stuff. So I think I've finished the JIT asserts, or maybe I actually finished it last week already, but I don't plan to add more asserts now. I think for this layer I'm happy with. For my Pi, we discussed this last week. I fixed all the self-type stuff in mixing, and also the boundary between Tensor and UOP is cleaned up. There were like something I was just using the UOP directly instead of like wrapping in a Tensor first to then do the ALU. So those are all cleaned up.
I've been thinking about this. Why do we want mixins? Why don't we want Tensor to just recall the method on UOPS? Like, why don't we just move all those methods to UOPS?
Because UPAT also use those.
UPET uses a few of them. Yeah, I guess you could keep mixins for UPAT. That's totally fine too. I'm just saying, like, move them off of Tensor. Add like a meta call on Tensor that intercepts them and unwraps the UOPS and then calls the UOP function.
Oh, that's probably fine.
Yeah, I mean it's not very different. I think we
Yeah,
could actually leave the mixins too, just for structural purposes. You know, we don't want like one huge class. But yeah, I mean I'd kind of like to like move everything off of Tensor into mixins.
I saw you have a comment on the gen stuff. You also want the UOP.gen.
Yeah, I mean I want everything to just like work on UOPS and Tensor is equivalent. Like,
So the tensor is just this class that has that's kind of mutable because the underlying UOP can be different. Slightly
exactly, yeah.
different. Okay.
The only difference, yeah, the only thing that a tensor, I mean, UOPs are immutable and tensors are mutable. That's the only difference.
That was really fun.
Yeah, I mean, I don't know. I got like stuck on like moving like I moved all the things to mixins that didn't need D type, and then I'm like, I don't know what to do for D type, but it's not really that hard. It's just gotta kind of beat down. I don't know if you want to take on moving more things to mixins.
Nope. There are also a bunch of hacks in Tensor. Maybe it's a good like motivation to remove those. I will talk about
Yeah.
this more in the assign, but I think MyPy. I added like one line stats for the MyPy reports. I think half of our lines are not typed, not like fully typed, and
Yeah.
part of it is the runtime. I don't know if we can do better there because a lot of the runtime types are like autogen, which is kind of ignore. So I don't know how improved we can make on that front. Then the other half is the lambda in general, because we use tons of lambdas in the rewrite, and we have a lot of tests to kind of make sure it's that type, but it's not really type checked.
Well, I mean, if they're lambdas, can't we type the list that we pass into pattern matcher? Have a callable that accepts UOPs and returns a UOP?
can try that, but I don't know how good my Pi is tracking this. Because
It
you
might
are
be.
basically asking my Pi to really run the rules to know what the return type is, right? I don't know if it's smart enough to say, okay, all these rules are this type, so any possible computed output from this is also that type. I don't think it's that smart.
No, well, I'm saying you could at least, like, if you make the list type callable that returns UOP, at least it could know that the rules return UOPs. Wouldn't help with the input type, and it's annoying with context too.
And it's annoying if your output is not UOP.
Yeah, that kind of shouldn't exist.
Yeah, so that's kind of the, unless we have a really big change on that front, I don't think my Pi can do any better there. Then the rest is probably some like minor thing, like there like some of the helpers that obviously returned like Boolean. We can have a pass, or can have a pass to add all the output type to those. So that's like less important. Then the final thing that I was most excited about was assign. Because assign is super broken, and so this started first when I tried to do the make disk assign lazy. And the thing is, if you ask Cloud to do it, Cloud will happily go hitting the wall and make 10 different changes in different places until the test pass. And when I read it, it doesn't make sense at all. Then then you will start to realize so many things are hacked around assign and disk. So I'm making progress on that. I'll probably keep working on this for this week unless I find something that can help with the Llama training. But overall, I find this workflow of using Cloud to go through Git history and to find a context around certain items very useful. I think that shows the importance of writing good PR and make it small. But my previous biggest issue working on the scheduler part was I just don't quite understand what certain UOP is supposed to be, because it can be very different from the actual implementation. Having like this, you can certainly read Git history and context a lot better than how I would do this, like with the Git blame and stuff like that. So you can see my change. I isolated a bunch of like errors and bugs and fixed some of it. I think so there are two major issues for assign. One is the order is not actually right. So that's the main reason in Tensor level we need to do a lot of realize in places. That's kind of we manually making sure the dependency is tracked correctly, which is not right now. Another is like disk. So disk, we used to have a check for disk in the Tensor level to say this device is disk. But that logic is not complete. What we mean by disk is actually a device that cannot do compute. And we kind of always guarantee the underlying buffer is contiguous. So that's the actual thing we need to make our like in different layers. And I think there's a better way to do it, because there's not really difference between like a disk memory to your CPU buffer if it's like one big memory. If you can do big cast on disk, you should be able to do that on your contiguous memory as well, things like that. So yeah, I think there's a huge potential. I think Rangify indexing is too long, so there's that. I don't know how it should be able to like be cleaner.
Rangify should be able to be cleaner. I agree.
Yeah.
Yeah, no, I mean,
I also find a bunch of rules that is just like no longer needed, or because the way we write spec and the way we write allow any length is kind of, if you just add it blindly, things will still pass, but it's not necessarily needed. So if I see it, I would just remove it, something like that.
Yeah. I've been working on a D-type spec. The other thing that I think would help make Rangify a lot shorter is I think tensors have the wrong D-type. I think that the D-type should actually be D-type vec, like D-type float vec, and the number of elements. And then after Rangify, it's just D-type float.
What do you mean by number of elements? The tensor?
In the tensor, yeah. The size.
So that's just a product of shape?
Yes. It's
Okay.
product of Vmax shape because it can't be symbolic.
I see.
And then it's the Rangify. After Rangify runs, it rewrites the UOps to be like D-type float, because that's what it is inside the range. And then index and jet become the same thing.
Oh,
Yeah, we currently have jet and R, but it doesn't have to be an R. We can put it as a parameter with a const.
so we can see this better once we don't have image.
Yes, yes. That's a lot of the blocker for a lot of this stuff.
Yeah. No, but I see the potential there.
Right.
Okay. Yeah, so I think my next sprint would be see if there's anything I can help with Llama. Otherwise, I'll continue with my happy refactor of schedule. That's me. Next we have FastGen.
Asm gem is merged 1.4 petaflops and it's used in Llama.
Great. You want to find flash attention kernel next? Are there good flash attention kernels?
I don't know.
Yeah, I mean, I think we should pursue both strategies in parallel of getting ours to be faster and trying to find one. It's a bit more complex than Gem.
It is.
Yeah. I'm hoping, I don't know, I'm going to email Anesh. I'll email him tomorrow and be like, are you actually seriously going to open source this? Like, is that going to happen?
They might be cleaning up the code.
I hope so.
I don't know.
Give us clean code. Good. Have your code. Clean it up.
It's
What else you got for the spread?
so AsmGen can't be used for larger sequence lengths. It goes out of memory.
Well, what can't be used?
AsmGen, the assembly gem memory issue.
Oh, the assembly gem memory issue. Does that just have to do with the fact that there's contiguouses?
I think so.
Yeah, I think we can clean that up. Oh, another thing if you're interested. So I added call. We should be able to remove the grad function off of custom kernel.
Mm-hmm.
Yeah, if you just replace, you can keep the API the same, but if you just want to replace that with call. And actually, if you want to go even further, you should be able to replace custom kernel entirely with call. So the first argument to call is usually you should be able to replace both kernel, kernel, and custom kernel with call.
Yeah, see, so you made define global also a param. Like it's just
Yes.
an alias now.
Yes, define global is just an alias for param now. So we only made one new UI, but I think we can unify. So the problem with like the problem with kernel right now is it has UOPs in the arg. Those UOps should actually just be in source 0.
Yeah, UOps and arcs are.
So yeah, I don't know if you're interested in this project this break, but I think yeah, priority 1 is looking for flash attention kernels. Priority 2 is refactoring kernel and custom kernel to actually just be called.
Is
It should
there
just almost work.
is there any value in running AMD's benchmark on the machine?
Which benchmark? Oh, AMD's real benchmark?
Yeah,
I mean, maybe.
I don't know how
like,
much of logging or things that we can learn from this.
Yeah, we know what they're doing. I mean, we just got to get a breakdown of how actually things are. We need to figure out where our time is going.
Oh, sorry, you were saying something?
So to be clear, I'm not gonna work on the memory stuff. Just the jamming.
I think you'll find the memory stuff is very related to replacing custom kernel with call.
Because then I can put the assembly in the kernel.
Yeah, you should just be able to. My theory about what's happening is that it's making extra copies, that there's extra contiguouses. And if you look at the code for, I mean, custom kernel is kind of a hack. But if you can replace custom kernel with call, and only do the contiguous if you need to, I think that'll fix the memory thing. So.
See. So it doesn't contiguous in call.
I mean, see if it does. If it's like permuted or something. If the kernel is expecting a different shape or drive the input buffer, then yeah, it needs a contiguous. So I don't know what your fast gem is expecting. Maybe it has to do with transpose, or maybe I don't know. Yeah, I would look into that and use that as a gateway to replacing custom kernel with call.
Right. And for this, I don't really have much work planned since we're left on SQTT.
I mean, yeah, it's pretty good. Pretty happy with where Viz is on SQTT. Yeah, I think it's pretty usable, and I think once we start to get our data tree assembly back in, we can start to see some real speed from it. Already helped me go from 53 to 55 teraflops on AMD UP Mammal. AMD has a Mammal.
And the Atom is so clean. I wish my Atom gem was like that.
Took a while, and it wasn't written by LLMs.
Yeah.
Yeah, top priority is flash attention kernels. Second priority is the custom kernel thing. I'll look at the memory thing and at least figure out what it is.
Next we have drivers. Also a deep here.
Yeah, so for the AMD, we can now handle all issues and we print them. And for not MI machines, we can also do recovery from these faults without rebooting the GPU.
Awesome. Why not MI machines?
I mean, we still have this issue that we need something else to reset for the IQL queue. It works with PM4, but not IQL, because they won't sync XCCs after the reset. I mean, they have the same bug in the AMD GPU. If they if I turn off the mass, like the analog of mass.
So I'm running the external GPU crash now. It's pretty slow. Does it have to do a full reset in between or not? Oh no, I just see start recovery.
Basically we
complete.
have. Yeah, the recovery should be really fast. We have. So basically, because we don't use interrupts right now, I mean, we don't have VFIO enabled.
Oh, you're polling for that.
Yeah, and actually only after 2 seconds. So,
Why?
Yeah. I mean, 2 seconds.
Why
I mean,
wait 2 seconds?
I can remove that, but I mean, for really fast kernel, it's just faster to not poll at all. Just not visit this path. But yeah, I can remove that.
Yeah, I don't think. I mean, 2 seconds, sure. Maybe wait 100 milliseconds or something.
Yeah. Okay.
Yeah, I mean, I would also
Lower
wouldn't like. Don't poll in a tight loop. Just poll in like sleep for a millisecond, like poll 1/3 millisecond or something.
Yeah. Okay.
Cool. Yeah, I think interrupts are not something we need. I'm totally fine with polling.
Yeah.
Another thing, like my computer gets brought down the whole world quite a bit. If I launch a forever running kernel, will it crash my computer? And is there anything we can do about that?
So I don't really get it. So why the launch kernel should crush your computer?
If it's like a forever running kernel. It seems like there's some like watchdog timer that if a kernel runs for like 3 seconds, it brings my whole GPU down.
Oh, with AMD GPU?
Yeah, so I have a Strix Halo laptop, so I'm running the AMD GPU driver.
Yeah. Actually, I'm not aware of that. Basically, I think for sure we will run something longer than 3 seconds. But yeah, I can just read the kernel. And
Does this test pass on AMD GPU or only AM?
so the only AM.
Only AM, the external GPU test crash.
Yeah, only AM.
Only AM. And I imagine, is there a reason we can't do it on AMD GPU or?
Potentially we can. I know, I'll try that. I mean, the only thing we can do is just try to recreate the queue, and that should work. But I'm not sure actually what will happen with AMD GPU, if it will disconnect our client or not. Yeah, I'll test this. Because actually we need to reset Mac at some point if there are some faults.
Got it. But yeah, no, this is cool. It's great. Yeah, I'm running test GPU crash right now. And it looks good. I wonder if there's. So it all just comes through this. Everything is through these SQ interrupts.
Yeah. So that's the only place where all hardware sends the interrupts to, including all faults.
By the way, Dave, I added you as a speaker. If you want to talk, you have to exit and re-enter the meeting. About the oh yeah, this.
Yeah,
Do you see this
that
bug?
was-
This Qualcomm bug?
Yeah. I started to take a look into this. There is something about caches and coherency, I think, with the CPU and GPU side. So I know. I'll fix that as soon as I can.
Cool. Yeah, that's priority number one.
Yeah.
And then priority number 3 is the NV trace on the 5060 over NV.
Yeah. So about that, in short, so actually everything works with the NVIDIA driver, so both 4090 and 5090, and there is also the decoder script, so that can parse all this format. So yeah, I'm still looking into that driver and just reading it. Actually, I've no idea, but our backend always returns zeros, so maybe it's something about some power things. I'm not sure really what they do special, but I know, so I'll continue looking into this.
My guess would be it's something similar to like the set performance clock on AMD, where you put it in like a non-throttling mode.
Yeah. Yeah, I'll take a look. I know it's not related actually to the profiling, because I mean we have pretty strange behavior to the profiling like request to the GSP, because it never validates them. That's kind of strange. It always returns like success to these requests. So I'll find that, because actually at least NVIDIA driver works with this. So yeah, but
And then any update on the Mac?
I've received nothing from Apple. So
They
it's merged.
verified one of them though, right?
Sorry?
They validated one of the things, right? Whatever they call it, the approval driver thing.
I mean, they validated everything I've sent to them. The problem is that we have mismatch with what driver validates and what they granted to us.
Is this still the vendor ID issue?
Yeah. Yeah.
Yeah, I mean, hopefully they get back to us. I don't know. If it happens, then it happens. I think that'll be great to have already once we start selling these boards. Yeah, lowest priority of all things.
Anything else?
I love seeing these exceptions. They're beautiful.
No, that's it.
Sounds good. Let's move on to Llama training.
So we have a 4096 sequence length model trained at BS16. I would expect a BS8 8192 sequence length to train about the same, just because the token counts per step match. 192 doesn't fit because of ASM gem. I do wonder if there's value in finding a fused Swiglu kernel.
That does like all the
Yeah,
gems?
it does the full FFN in one kernel, and it doesn't. Yeah.
How fast do you think you can get our flash attention?
I'm at 330 flops right now.
Oh, and then do you know what percent of the training time is flash attention?
It's quite small. A192 is very small context length. I think like Gemini is like 70% is gem.
Our gems are so fast.
So currently with ASM gem, the output gem is still quite slow.
Really?
Yeah.
Why? Well, you say slow, how
So-
slow?
It's like 300 milliseconds.
With
26
flops.
flops. 26.
26?
Yeah.
Is it even using SMGem?
I think it does hit ASM gem because I see the custom kernel running.
Oh. Yeah, let's get the dimensions of that. We should test that as
We should fix it. I tested every single gem and it's by far fast.
Yeah, okay, it sounds like there's some bug here or something.
Also, I
But yeah,
found
no-
that AMD 3 is slower than AMD 4.
Power limited?
I don't think so. But like flash attention is 330 on AMD 4 and only 300 on AMD 3. And I don't
Right.
think I saw any
AMD4
of it
also has the
before.
AMD4 has the RM mod. Doesn't have the RM mod. AMD GPU. If that's different in timings.
Maybe. All my testing is done with AM.
That doesn't seem that significant. The 20 T-flop
it's
thing
not-
sounds like 26 T-flop sounds like a major problem. It sounds like it's 50x off from where things should be. But yeah, if you
Yeah.
could get benchmark to output a breakdown of where our trend's going. Yeah, then I think the goal for your next range is pretty obvious. Just yeah, that's closer to AMD's.
Yep.
Really?
Next, that?
Heard Julie in the background of column.
Yeah.
Yeah.
You guys good?
Okay.
I think we're good.
Okay. So next we have the Decomp.
Yeah. So yeah. So I mean, in the long decomp is done. It's I mean, it's running on everything except for if there's no shift support or PTX. Yeah. I mean, obviously we could just do multiplication when we don't have shift support. I don't know. Yeah, the reason I haven't done that yet is because it's I feel like a lot of the decomp stuff is like already hard enough to read, and then like having multiplying by 2 to the whatever, or dividing by 2 to the whatever makes it even harder to read. But I can just write a little helper that does that. So it's not a blocker, not a real blocker.
Do we remove PTX?
I'm pro removing PTX. I'm sick of it. Doesn't do anything for us. You just play that. Stupid.
Yeah, I mean,
Reason.
yeah. So
Reason for anything?
also.
I don't think we really use PTX for anything, right? And it's also not faster.
Yeah, so I would either delete it or if there's some, I mean, it's only really one thing that causes this problem, right? I actually think that this might not be worth deleting PTX over because, like, it's because you're doing decomps in the wrong order. The shifting is the same problem too, right? That PTX address rewrite should be the absolute last thing that happens.
Yeah, I mean, the shift
Yeah, but
thing.
you have a lot of things that wants to be the last thing that happen and don't interact with others. Yeah. It's like a regular decomp already want to be the last thing so that it doesn't interact with other symbolics that would like change its order or things like that.
Yeah, but no, the decomp should happen before. So now that we're talking about like assembly backends, we can think about what the next stages are. Decomp should happen before instruction selection. And like the PTX thing for the addresses looks a lot more like instruction selection than decomp. But either way, I don't care if PTX is skipped. I mean, we're behind on compiler pairs got to get done, and image equals one's
Yeah.
got to get done.
Yeah.
So yeah, I would let's not get distracted by any of this. Skipping for shift is fine. Skipping for PTX is fine. We can deal with
Yeah,
that
because
stuff
the problem
later.
with shift is that we rewrite multiplications to shifts, but no shifts to multiplications if I remember correctly. I think there's no decomp that goes the other way around.
Yeah, there shouldn't be a decomp that goes the other way around. You should do it all as multiplication and then have it all get rewritten to shift.
Yeah. Okay. Sure. Anyway, that's a later problem to solve.
Yeah. Which backends don't support Shift?
NUR doesn't support it. I think NUR is the specific one that doesn't support it. If I remember correctly, it's like NUR doesn't support specifically like shifting by a variable amount or something like this. I don't know. And it's only certain backends don't support it.
Do you ever shift by a variable amount? Because that's a different problem. Multiplication can't do that.
Oh, that's true. Yeah, you do, because you do like a count leading zeros and then you shift by that amount.
For what?
Like for instance, well, I guess we're not doing, okay, so for instance, in the float example, you have to do this because you
No, in
okay, yeah, you don't have to do this for long
decomp,
decomp, but in the float example, you have to do this if you want to have, can you stop? You have to do this for denormals, but I guess if we do denormals or 0, then you don't have to do this.
Yeah, I don't care about denormals. This is just for decomps. For in64 decomps. This should work without
Yeah, no,
shift,
you don't. There's no count leading zeros for that. Yeah.
Yeah. Okay. Great. Yeah. I don't. Yeah. Regardless, whatever it is, it's fine. If we can delete the 3 fry rules, that would be great. But we really got to get to the compiler carefully now.
Yeah. Wait, I saw that message about. So it's you tried deleting those and it was slower. Jenny, what were you saying about like you're saying something about int32, like maybe there's some application for int32. I didn't totally understand what you're saying.
So I don't know if you have tried this, but if you just delete that 5 rules for 3.5 and let the long like emulate that, you will see the output kernel is like 10% longer. I just guesstimate based on the ALU counts. So that means those rules are useful in some way, right? It's like it's better, like the output kernel is better with those rules than without. But those rules are also only applied to the int32 and int64. 64? Yeah, 64. Imagine the same rules should be generic to say int16 to int32. There's some relationship that is always true between certain D types that it's either, so the conclusion here is either our decomp can just in general be made better, the way that it's always like fit into 232, maybe there's like missing opportunity, then we should be able to fully mimic this this hack. Or there are something that's just generically true and we can apply that to smaller ints or like other D types. That was my whole point.
I see. Okay. Yeah. I mean, it should be applicable to smaller D types. I have to look at it, but I see no reason why it wouldn't be applicable to.
I think it's. I would. I don't know how important this is, but I would lean more to maybe we just need to improve in 64.
Okay.
But again, it's really not that important. So up to you. I think other things are more important. This is just when we remove the rules. Yes, the hack is bad, but also we also want the best version of the generated kernel we can have. So it feels less satisfying to remove rules, knowing that the kernel will be worse.
Yeah, no, I get that. Yeah, that makes sense. Okay, what else? So the other thing with long, that was interesting. So there was that bug with AMD, which is fixed now. But that was a result of the fact that I think the AMD uses O3 when it's compiling, like under the hood. And so as a result, there was this UB that we were encountering, because we were overflowing like a signed integer. And I don't know. I just thought like maybe it would be useful to like add a flag that allows you to compile with UBSAN, and like run some tests with that and see if that's if we run into anything that feels like it's believable that we'd run into some sort of bugs, or fix some bugs with that. But I don't know. I'm interested to hear thoughts about that.
Yeah, I mean, I think it's something that can be done, but it's not high priority. The highest priority thing here is getting through the compiler thing and getting to image equals 1.
Yeah. Yep.
So
Yeah.
let's get those things done, and then we can talk about more things.
Okay. Yeah, that's pretty much it. I guess the other thing was CI. It seems to be, at least when I went through the scroll back for like ever since I made that change that made the PRs not save their caches, we haven't had any failures on master related to like connecting to the internet. So either that means that GitHub Actions internet got really, really good and like they fixed it,
Helpful.
or they made a difference.
Cool. Yeah, no, I'm glad. And that seems like a good fix.
Oh,
Yeah,
is
and
the
I merged-
lib clan thing fixed?
Yes, that is fixed. So that's the same
Wow.
bug as the. It's not fixed. It's just skipped. It's the issue is the same bug as that metal compiler thing, where when you load metal compiler, it loads its own LLVM, and then because the dynamic linker on macOS is not smart enough to reload LLVM, it breaks when you try and open libclang.
When I try to fix it for me locally, Cloud also suggests you just load the LLVM into some global or scope so that it will link to the same object.
I tried a little bit of this. I mean, so one of the problems is that metal compiler loads a different version of LLVM. So that I don't know how fixable that is.
Yeah, it's again also probably not very important. It's just slightly annoying that when I run the test locally with auto, something would fail.
Oh no, it's
Yeah.
fixed. It just skips them. It's fine.
Yeah.
Skip is fine. As long
Skip
as
is
Yeah,
fine. Yeah.
This is frustrating, and it really feels like there should be some way to solve this, but I don't know.
No, I so much don't care about this. The auto test should always pass for you now, and not only should it pass, I added a benchmark test to make sure it keeps passing. There's now a benchmark test on Mac to make sure it keeps passing, and I want to get a benchmark test on Strix Halo to make sure it keeps passing. And every time that test fails, we have to add something in CI that would have caught the failure. Like, yes, we now have tests in benchmark, but those tests should never fail.
It should be fast.
Yeah, it's fast. Yeah. How much work did you do? Most of that? Like, it got a lot faster.
Kind of. I just keep skipping things or make things smaller until it runs within a minute on my machine.
Yeah. Cool.
Yeah, I think we can do better for those like test separation. I try some curation for the thing we discussed earlier to move things into units as much as possible. And use null as much as possible. We can probably do better. I think a lot of the test ops are like, do we really need like 20 different kinds of get item for every backend? Probably no, something like that.
No, I think we don't. I think we
Yeah,
don't.
but I think
we can.
for now it seems to be fine. So
Yeah, well, I
as
want
we
to
have
move some
updates
tests.
to systematically make it a lot faster, I don't think.
I want to move some tests to null. That's the pass with the null. I mean, so many things like test TQDM that passes with the null, like things that don't even use a device. And then I'll have the unit test runners also run the null test with the null device.
Yeah, that sounds fine. When you do this with whichever LLM, just making sure it's not hard-coded the device.
Yeah, no, I'm doing it pretty carefully.
Okay, that's good. Cool. Okay, if that's it, next is assembly.
Yeah, some good progress. I mean, last sprint I got, the big thing I did was I switched out Remu. So now the emulator being used is the Python, and with almost no speed regression. So it's compiling the instructions. The instructions are all in UOPS. So it's actually just it's generating Tinygrad programs to run instructions. And the key to making it fast was not to compile each instruction, but instead to compile it with the registers being dynamically read. So it uses PC. It has basically a decode stage that reads the registers and then it reads what the register should be and then actually reads from those registers. And then that like made it 10x faster. And it's pretty similar in speed to Remio. So that's it. I merged RDNA4 support today. So we'll have emulators for RDNA3, RDNA4. CDNA has a lot of weird stuff. The RDNA4 one still has some bugs too. But it's done in a very nice way where I didn't just tell an LLM to write an emulator. It's parsing all of the P code from AMD's PDFs. So it's pulling all of the pseudocode for each instruction out of AMD's PDF. So we have a pretty nice environment for all of AMD's assembly. I still haven't moved it into TinyGrad proper. There's still a few rough LLM edges, but if you guys look at the code, hopefully you'll see it's not too terrible. I've aggressively gone in and cleaned things up manually. So I think it's not my highest priority this sprint. My highest priority this sprint is to figure out the D-type stuff, some of the other call stuff that's not the kernel stuff, basically to try to finally get Llama to be fast. The startup time with Llama is way too slow. I'm basically gonna work on that.
Any quick comments on the x86?
And this new one's a lot better. This new one is so my big complaint about the first one is that it was doing instruction selection after linearization, and like at that point you're just rewriting LLVM. But the really interesting thing that we can do in TinyGrad is do instruction selection before linearization, and then we can intelligently linearize based on register pressure, basically. So yeah, I think there's something there. I guess maybe this week I'll also start on the RDNA3 assembly backend. LLVM is very, very good at compiling x86 code. It's terrible at RDNA3. Like the things that I did with AMD UOP matmul are totally doable with TinyGrad transformations, and that code is almost 2x faster than the AMD UOP matmul, which uses LLVM. So, very possible to get real speed out of these things because of how GPUs are. They're a lot simpler, and so they're just very different. The scheduling is very different between CPUs and GPUs. And then if I also do warp specialization, I think the scheduling, I think everything just becomes a lot easier if you can warp specialize, because you can independently optimize your GMEM to SMEM and then your SMEM ALU kernels. You can like optimize those warps, and then like one of them is going to be your limiting factor, but you can work on them independently. Yeah, some combination of that stuff. The other thing I want to do this week is work on the USB firmware. So yeah, the box is now set up really nicely, so I can reflash the firmware a ton of times. I almost have USB enumerating, and then it'll be a question of getting PCIe to work. And then when PCIe and USB both work, we should be able to finally get fast USB 3, which is the feature that Common wanted for a while.
Are we getting the music example or app?
Oh, you want the music app? That was Claude for 10 minutes. Actually, the music app found a few bugs. I posted that one bug that the music app found, and it also generated a kernel that crashed my GPU until I added a contiguous. So, yeah. That's kind of why I didn't post the music app. It's actually a pretty bad example of TinyGrad. Because it just concatenates all the nodes together, and it's like a concatenate with like 160 tensors. And
That sounds familiar.
Yeah, we're not really designed to concatenate tensors.
No, we just need a better Latin for this and find that optimization and things like that.
Yeah. Well, the drums it was able to do using tensor operations, but the notes it did with a big concatenation. I rewrote the drums as basically the drums is an expand
Mm.
in every shape.
Oh, by the way, I changed your expand outer loop to unroll outer loop. I think that makes more sense.
What?
When you generate the outer range, you unroll
Oh.
outer range. That was called expand. I was so confused.
Oh yeah, I mean the outer range stuff is super broken. We have to basically get call to work. So there's two aspects of call. There's the call replaces kernel and custom kernel, and then eventually we're going to be left with chains of calls, and these chains of calls can use tinygraph graph rewrite rules to create GPU command buffers. This also gets to like the correct way to do web GPU export and stuff. But there's the other side of call, which is another thing I want to work on this sprint, to get call to work with derivatives. And to get like basically to replace reduce with scan. Right? Because we have reduce right now, and reduce has this UOP add, but you should be able to do a reduce with any arbitrary function. So yeah, replace reduce with the scan.
Great.
Yeah, but the main thing that I want done at the end of this sprint is faster Llama. However I go about that. It shouldn't take so long to run. I mean the Python time. Like it shouldn't take 3 minutes to spin up the Llama script. If using things annoying.
Sounds good. Okay. Other issues, bounties. I see Flata here. Are you trying anything with blocks? Does it work?
I got the eval working. I'm running it right now. Just want to make sure I got the correct loss on that because I'm using the weights from the from Hugging Face. So I'm on that, but I think the training loop should be pretty similar as well. So yep, still progressing through.
Issues.
Want to change the null backend to not give you zeros. Many things pass on the null backend because zeros happen to pass if everything has zeros.
Yes, that's the annoying part.
Yeah, I'll fix that. I'll have it return nans or something. Or just be the wrong shape. I have the GLM flash 50 tokens per second bounty. Guy's pretty motivated. We'll see if he comes through with anything.
I think I don't know. We will see if we can get good things out of this. No, I think for this is to the bug you post earlier and the 2 PRs immediately after. It's like if you ask Cloud to do it, it would give you that 2 solutions
I
much
know.
immediately.
I know.
Then you can try to. I think for other people who want to try this workflow, a lot of it really need to understand like why certain things was certain way and what spec is good or not. So
No,
if I
totally.
don't
I mean,
if I don't see a clean solution, I will merge mine. Good.
oh, you have a clean solution for that.
Well, I just merge after the reduce to egg if it's referencing to the same range.
Yeah.
But not as a separate rewrite step, and check that with the rewrite context.
Yes.
So the problem for let to PR is they try, then CI fast, they ask Cloud to fix it, then it went to a spiral of fixing random stuff. I think
Yeah.
that just wouldn't work.
Yeah, it shouldn't be a lot of lines. It's one straightforward problem.
Yeah. Even there,
no,
I think
yeah.
there are more refactors that can be done there. It's just very hard for like external contributor to first refactor those stuff.
And you have to
given
spend some
that-
time understanding it. You have to go into Viz. You have to understand what's happening and be like, oh yeah, find a minimum example, and then be like, this is what it should be.
Yeah, I think an interesting example is, if you ask Cloud, it would say it's because it's generating two ranges. But then you should also ask, like, how come it's not a problem if you don't do other stuff and just call that function, things like that. There are a lot more that can be explored and understood before proposing a solution. It's like even asking Cloud to do this helps the output. Okay.
I'll add it to humans.md. They should all read it before.
Oh, and we probably want to either maintain the cloud.md or don't have that.
I kind of feel like we can delete it. It's kind of crappy. We can just delete it.
Okay. Cool. Sounds good. I think that's it for this meeting. Thank you, everyone. See you next week. Bye-bye.
Bye.